In order to find the derivative of this function, we're supposed to convert the cube root to exponent first. So I have y is equal b to the third minus x cubed raised to power 1/3. Okay, so derivative of it. So if y prime is equal, again I'm going to use this formula. So please notice that my problem doesn't have constant, right, at the front of the parentheses. So there is invisible one. So if there's invisible one, we don't write it. So we're going to start from the exponent. And my exponent, n, is 1/3 times u, where u is everything, whatever I have inside of the parentheses. Okay, so this is my u. So I have b to the third minus x cubed. Next, I have to subtract 1 from the exponent. So I have 1/3 minus 3/3 times derivative of the content of the parentheses. So I have times the of b to the third minus x cubed over dx. Okay, so I have y prime is equal 1/3, and I have b to the third minus x to the third negative 2/3, and I have derivative of the difference. So derivative of constant, because b represents constant, is equal 0. So I'm not going to write it. Just copy down negative sign. Derivative of x cubed is 3x squared. Now we're supposed to reduce 3 and 3 over here. So I'm going to have y prime is equal negative x squared times b cubed minus x cubed to power negative 2/3. I want to convert negative exponent to positive, so this is equal negative x squared over b cubed minus x cubed to power 2/3, and I can convert the fractional exponent to the radical. So this is negative x squared over cube root, and I have b cubed minus x cubed to the second power. And this is my solution to this problem.